All right, so we're going to look at two special right triangles today, the 45, 45, 90, and the other one is the 30, 60, 90. So you're going to get this paper here. I want the phones put away. They should not be out on your desk. I'm actually rather excited about today's lesson, which for you probably means a great big sigh.
I'm so excited.
Because I learned a different way to teach it, and I love it. And actually, you should love it too, because it makes your life easier.
Are we not using our notebook?
You will not use your notebook today. Well, you're going to use this paper. All right, so question number one. I want you to think to yourself, we're not going to say anything out loud yet. You should think to yourself, what are the measures of angle B and C? And I want you to explain how you arrived at your answer. Look at the picture. The picture should tell you the angle measurements. Of course, it is kind of obvious. Perhaps, if you're awake. Why? It is. It's an isosceles. What kind of isosceles triangle? An isosceles right triangle. So the measure of angle B is equal to 45 degrees. The measure of angle C is equal to 45 degrees. Your explanation can be because it's an isosceles right triangle, which means that two angles are equal. Or if these sides are equal, what do you know about the angles opposite those sides? They're congruent also. So if two sides of a triangle are congruent, then the angles opposite those sides are congruent. Didn't we have a theorem that said that? So because this is 90, and all three angles add up to 180, you should know that there's 90 left over for those two, and if they're equal, you have to cut 90 directly in half, and doesn't that give you a 45, 45? From this point out, they do not have to give you any angle measures for that triangle other than to tick mark the legs. If the legs are tick marked, you need to automatically be able to identify, oh, that's a 45, 45, 90 triangle. If I told you that the length of this leg was 2, what do you know about that leg? It's 2 also. And we're going to figure out what the hypotenuse is here in a minute. So then the second question says, write the Pythagorean formula. Write it down from your memory. And then what does it say to do? Yeah, write an equation in terms of x and h. Look at the picture. Doesn't the picture of x and h as the side lengths on that triangle? By substituting in the side lengths into the formula. So take your formula and substitute it in. So your legs should represent A and B. Your hypotenuse h should represent C. Then I want you to simplify that further. That's where the hard part comes in, because you're not going to recognize something mostly. So go ahead and try to simplify it further. Get it as simplified as possible. How many of you stopped here at simplifying? You didn't want to admit it, but you did. What do you know about these two? They're the same variable, which means they're like terms. If I have 1x squared and I add another x squared, how many x squareds do I have? 4. So your step further is that you have 2x squared is equal to h squared. This is what they were looking for. But remember, we're trying to find what h is, not what h squared is. So question 3 says solve for h. Your answer must be in simplest radical form. So I want you to take this formula, put h squared on the left, and then 2x squared on the right. I want you to solve that formula for h, quietly to yourself. What did you do to both sides to solve for h? Yeah, I don't want to divide by 2 because I'm not solving for x. I'm solving for h, right? So focus on your h. If it's squared, you take the square root of both sides, right? So if I take the square root of this side, I'm going to get an h equals. If I take the square root of this side, be careful. Can I take the square root of 2? No, it stays under the radical. Can I take the square root of x squared? Yes. So the square root of x squared is x. The 2 stays underneath the radical. So h actually equals x radical 2. So I want you to go back up to the picture, and I want you to put, instead of h, I want you to put x rad 2. The purpose of this is, and so question 4 down below says redraw the triangle, but I don't want you to redraw it yet because I want you to redraw it differently. The purpose of this is that we've got x rad 2. So I'm going to prove to you that it works. Pick a value for x. Any value for x. 4. Let's go with 4. So if x is 4, what's this side? 4. According to this pattern, what's this side going to be? If x is 4, what's the hypotenuse? 4 rad 2. Isn't that what the pattern's saying? Whatever the leg is, multiply that leg by radical 2 to get your hypotenuse. That's what the pattern says. And so let's apply Pythagoras Theorem to see if that's correct. 4 squared plus 4 squared equals 4 radical 2 squared. Right? What's 4 squared? Catherine, can you not see back there? Okay, I'll switch your seat tomorrow. She's over there squinting. So I've got 16 plus 16. When you square 4 rad 2, you've got to be careful. You have to square the 4 and square the radical 2. So what's 4 squared again? 16, but remember the 4 is being multiplied to the radical 2. What's rad 2 times rad 2? Just 2. What's 16 plus 16? 32. What's 16 times 2? Doesn't it work? Would you agree that that pattern works then? Okay. So if I change x to a value of 2, this is 2, 2, what's this one? 2 rad 2. But here's where the problem comes in. What if I make your what if I tell you your hypotenuse is 10 rad 2? What's the legs? 10. 10 and 10, right? That's no problem. What if I told you that the hypotenuse is just 10? Now are you going to have some issues? Yes. So let's look at an easier way to solve this. So in number 4 down below, here's what I would prefer you do. Let's look at this again. What is the coefficient? Just look at the x's. What's the coefficient of x? 1. The coefficient of that x is 1. Technically, what's the coefficient of this x here? Not 1. It's really radical 2. Even though it's behind the x, we always put radicals at the end of the number. So the coefficient here is really radical 2. What I would prefer you memorize for a 45-45 triangle is this. So put your triangle down here. Put your tick marks in. There's your tick marks. I would rather you memorize that this is 1, 1, radical 2. And so would your Algebra 3-4 teachers next year. And I'm okay with that. And we're not going to summarize in a sentence. Cross that out. We don't care. So then, here's what we're going to do. The back has a bunch of problems on it. Well, 4 of them. And you have all the answers to them. I'm going to show you how to solve the problems. With 45, 45, 90 triangles, there's an easy way and a more math-consuming way. Depends on what kind of problem you have. Questions 1 and 2 are exactly alike, and questions 3 and 4 are exactly alike. So with 1 and 2, we can solve for x and y without any math at all. The minute you recognize that you've got two tick mark legs, you should know that it's a 45, 45, 90 triangle, right? Immediately in your brain, I want that to kick in. But they've given you the leg. If this leg is 9 centimeters, what's the measure of this side? It's also 9 centimeters. What's the hypotenuse? 9 radical 2. All right, so you figure out number 2 based upon that, because they've also given you leg on number 2. What'd you get for this leg? For the leg? 5 centimeters, right? And for the hypotenuse? 5 radical 2, and it's centimeters, right? So that's not so hard. You're like, this is great, and I have 50 problems like this, right? Well, I'm going to show you something before we do 3 and 4, because 3 and 4, look what they give you. Hypotenuse, it's just 3. If they had said 3 rad 2, it'd be easy. You'd go, oh, if it's 3 rad 2, well, that's 3 and that's 3, right? But it's not. So it becomes more complicated. So I'm going to show you a method. We're going to do it on one of the easier ones first, and we're going to apply it to the other 2. So we already know what the side lengths are, so I'm just going to prove to you that my method works. When you see these special triangles, you have to identify what kind it is. It's one of 2 kinds. This particular one's a 45, 45, 90. Then what I would like to see you do is underneath there, I want you to put our pattern that we put on the triangle on the reverse side here. Across from this 45 degrees is a 1, and across from this 45 degrees is a 1, and across from the 90 is a rad 2. Agree? So then what I would like to see you do is underneath your 45, 45, 90 here, I want you to put 1, 1, rad 2. Get used to that. Memorize it. Use that pattern. We're going to create fractions. On the triangle you have been given, these are the legs, right? These are the legs here. Originally, what were you given for the legs? 9 and x. So you're going to put 9 here and x here. And then underneath this is a 2. This is your 90 degrees, right? So across from 90 degrees, they gave you a y. So these are the 3 sides of the triangle that they have given you. Then I want you to put equals and equals. It looks like a proportion, but a proportion isn't equal to 3 ratios, is it? But haven't you been given 1 full ratio? And I'm telling you right now that all 3 of those fractions are equal to each other. So can't I take 2 and set them equal to each other at a time? Can't I set those 2 equal to each other? So if I'm to find x, I'm going to set up the proportion 1 over 9 is equal to 1 over x. Now logic reason states that if both of these are 1, then both of these have to be 9, right? All right, so these ones are really easy, but we're going to cross multiply and solve anyway. If I cross multiply, don't I still get x equals 1 times 9 is 9? Don't I still get 9? Does it work? Didn't we get 9 before? Okay, I'm just proving to you that this method works. Then to find y, we're going to set these 2 equal to each other, not these 2, these 2. Always keep the full ratio that you were given and set that always equal to the other one. So I've got 1 over 9 is equal to radical 2 over y. Isn't this similar to our similar figures that we did with the scale factors? We're using that same theory here. So cross multiply. 1 times y is y. 9 times rad 2, you will always put your radical after the number, so it becomes 9 radical 2. Done. Same answer as we got before. If you did it number 2, you get the same thing. My point here is you can sidestep this method if you are given the legs and they're nice, easy legs, like just a plain number. So you wouldn't have to go through all this stuff in red. But you do have to do it with 3 and 4. So let's look at 3, and I'm going to let you do 4 on your own. So the minute I see tick mark sides for legs, I'm going to immediately say, oh, it's a 45, 45, 90 triangle. And immediately upon that, I'm going to use my pattern. What's the pattern? 1, 1, rad 2. And I'm going to make fractions and equals. And then I'm going to have to put the sides in the appropriate place. You can't just put them in wherever. So underneath my 1s goes my legs. My legs are what? X and Y. And across from the hypotenuse is 3. That's your 90-degree angle. is 3. So this is the only full ratio that I have. So to find x, and this requires a little bit of work, I'm going to set these two together, equal to each other. So I've got 1 over x equals radical 2 over 3. You're going to have to recall some radical knowledge from algebra 1, 2. So I cross multiply to solve. When I cross multiply, I'm not going to write it as rad 2x. I'm going to write it as x times radical 2. 1 times 3 is 3. My goal is to solve for x. What's happening between x and radical 2? They're being multiplied, so how do you solve? So I'm going to divide both sides by radical 2. And it appears that I have an answer of x is equal to 3 over radical 2. What's wrong with that answer? You cannot have a radical in the denominator. You're allowed to have it in the numerator, but not in the denominator. So we have to rationalize the denominator. Do you remember that from 1, 2? How do you rationalize the denominator? Whatever the denominator is, in this case it's radical 2, you're going to multiply top and bottom by rad 2 over rad 2. So I actually get an answer for x of 3 radical 2 over, what's rad 2 times rad 2? Just 2. Now you might have to reduce your fraction. You can only reduce what's outside the radical with what's outside. So the only numbers I can look at to reduce are 3 and 2. If they don't reduce, so I leave them alone. I cannot reduce what's outside of a radical with what's under a radical. So I cannot reduce these two. This is my final answer for x. So x is 3 radical 2 over 2. What do you know about y? It should be the same, right? You can go through and do the same work again, and you could set these two equal to each other. You're going to get the same thing. There's no difference between these two and these two other than one has an x and one has a y. So you can shortcut your work on the 45/45s by saying, okay, I found one. If you're comfortable that you did your math correctly, then the other one is the same thing. So you go ahead and do number 4 on your own, following the same method. You got the answer down below for 4. Don't forget to start with the 45/45, get in that habit. You cannot assume that I know that if you find x, that y is the same thing. So you still have to write out y equals. So how'd you do on that? You okay with that? Okay. So then, 30, 60, 90 is going to be very similar to this, but it's just a different pattern. So we're going to come up with a pattern for 30, 60, 90 the same way that we did with the 45/45. So here's your new sheet. Okay, so let's go through the whole thing here with the 30, 60, 90. So you've been given a picture of an equilateral triangle. They've told you down here that triangle ABC is an equilateral triangle. We get a 30, 60, 90 triangle from an equilateral. So the first question says, what is the measure of angle A here if it's an equilateral triangle? 60. So what's the measure of angle B? And notice that they don't call the third angle angle C because there's two angles associated with it, so they call it ACB. Shouldn't that also be 60? Then they tell you that CD is an altitude of the triangle. It's coming from a vertex and it's hitting the opposite side at a right angle. So we could have identified that it was an altitude without them telling us that. What does that altitude do to AB? It bisects it. So you want to put a tick mark here and a tick mark there. Here a tick mark, there a tick mark, everywhere a tick mark. See, I told you I'd sing for you. No?
That doesn't count.
Oh, okay. So put on there, right on there, it bisects it. Based on your answer to problem 2, find the following lengths in terms of x and write them on the diagram. So if AC is 2x and CB is 2x, what is AB? It's an equilateral triangle, right? So shouldn't it also be 2x? So if this whole thing across here is 2x, what's AD?
X.
Just x. And what's BD? Just x. So put an x here and an x there. Wait, here and x there and x everywhere and x there. Isn't math fun? All right, so then remember CD is an altitude, so what does CD do to the angle ACB? It bisects it. So you can put an arc mark here, arc mark here. So what's the measure of angle 1 and angle 2?
Oh.
30 and 30, right? 30 degrees and 30 degrees. So we can put a 30 degrees here and then 30 degrees there, put a 60 here and a 60 there on your picture. Then they want you to highlight DBC. So highlight from here. This is all we care about. So that's where the 30, 60, 90 comes from, is that equilateral triangle. They want you to write the Pythagorean formula and write an equation, so we want to go through the whole thing again. We don't have enough room down there, they didn't give you enough room, so we're going to do it off to the side above here. We have this side is x, this side is 2x, and we don't know this side in terms of x, it's h. Don't you think we're going to find that altitude in terms of x? Can't we use Pythagoras Theorem? So we're going to start off with Pythagoras Theorem. These are the legs, right? So my legs are h squared plus x squared equals my hypotenuse right here is 2x, and we're going to square that. What is 2x squared? What's this squared? 4x squared, right? Solve for h. What are you going to do? Subtract your x squared. If I subtract an x squared from both sides, what do I have? 3x squared. Now solve for x. Or, sorry, solve for h. What do? Take the square root of both sides. What's the square root of h squared? H. Can you take the square root of 3? No, so it stays underneath the radical. What's the square root of x squared? It comes out in front. Isn't h equal to x rad 3? Take away the x's. We've got x, x rad 3, and 2x. Take away the x's, and I want you to write down below here. We're going to rename that triangle because we want to get the x's out of there. Make sure you put in your 30 degrees and your 60 degrees as part of your picture. According to that picture above, this was x. But I'm not going to write x. What am I going to write? Take the x away. What do you have left? What's the coefficient of x? 1. Right? Remember on the 45, 45 wasn't the x side 1? And across from the 60 we had x rad 3. I can take the x away. What do you have? Rad 3. And the hypotenuse across from the 90 was 2x. Take the x away. What do you have? 2. I want you to memorize that. So we're going to take a 30 60, 90, and I want you to memorize the pattern that across from 30 is 1, across from 60 is red 3, and across from 90 is 2. That's what we're going to use to solve our problems on the other side, just like we did with the 45, 45, 90. Are you ready? All right, so flip it over. The 30, 60, 90s are not as easy as the 45, 45, 90s. They are more difficult. So let's start with number 1. Let's use the method that I taught you before. The minute you see a 30 degrees here, I would immediately put 60 degrees here and identify it as 30, 60, 90. It's your job to memorize that pattern. Cross from 30 is 1, then rad 3, then 2. They have to go in that order. We're going to make fractions, equals, equals. And then across from your 30, so stick with the 30, not the 1. Across from your 30 is what? X. It's vitally important you put the right side under the right number. That's where you're going to make your mistakes. Across from the 60 is what? Y. And across from the 90 is what? 10. So we have our 3 ratios. This is the only full ratio that we have. If you want to, we could reduce it to 1/5, couldn't we? You can. And so if this is 1/5, what's X? We can see that automatically right away. So if you want to, you can reduce this to 1/5 and use it as 1/5. So when we find X, we're going to set these two equal to each other. So X is 1 over X is equal, for your note purposes, I want you to go ahead and do this. So when you cross multiply, 1 times X is X, 1 times 5 is 5. So X is 5. The Y is a little bit more difficult, so we're going to set these two equal to each other. Radical 3 over Y is equal to 1 over 5. That one's not as easy to see, but if you cross multiply, Y times 1 is Y, and then radical 3 times 5, you always put the whole number in front of the radical, so it becomes 5 radical 3. Let me just go back to the pattern just for a minute though, so you can see it. Remember that this is X. It just happens that their X is our X. But this is X, and if X is 5, across from the 60 was X rad 3. So if X is 5, isn't this 5 rad 3? And then if this is 2X, 2 times this is 10. Do you see how that clearly follows the pattern? This is one of the easier ones, but I don't need you to recognize that anymore if you can just go through this. You don't have to worry about that. Because, go ahead and do 2. 2 is another easier one. But go ahead and do 2. Actually, 2 is not easier. I take that back. Well, no. Let's do 2 together. So we have our 30, 60, 90. And I'm going to immediately put 60 degrees in the picture. What's your pattern? 1, rad 3, 2. Make your fractions. What goes underneath the 30? X. What goes underneath the 60? 6. And underneath the 90? Y. So our full ratio is this. It cannot be reduced. You cannot reduce the 3 with a 6. So to find X, we're going to set these two equal to each other.
Our rad 3 is under the 30.
No. Nope.
Whatever
No, I didn't. Same thing, right? Do.
they- Oh,
Did you write it down wrong? Okay. Alright, so then we're going to solve this. Cross multiply, I get X radical 3 is equal to 1 times 6 is 6. When I divide by radical 3, I get X is equal to 6 over radical 3. Can I have that as an answer?
No.
No. Rationalize it. Rad 3 over rad 3. And so I get X is equal to 6 radical 3 over 3. Can that be reduced?
Yes.
Yep, because I have to look at the numbers outside the radical and see if they can be reduced. They can be. The 3 goes into the 6 twice. So X is actually equal to, fully simplified, 2 radical 3. So there's my X. Let's find Y. So y, we're going to set these two equal to each other. So you got radical 3 over 6 equals 2 over y. I cannot cross cancel the 2 and the 6 because this is not multiplication, it's an equals. You can't cross cancel across an equal sign. You can, however, cross multiply. So we've got y times radical 3, 2 times 6 is 12. Divide by radical 3. And we get y is equal to 12 over rad 3. Is that your answer? Nope. And so we get y is equal to 12 radical 3 over 3. Is that my answer?
No.
Nope. So this 3 cancels into the 12. So finally, my answer for y is 4 radical 3. Fairly painless, isn't it? Trust me, this is a lot less painful than it could be. This is fabulous. I love it. So excited. Can't stand it. So do 3 and 4. Try to do those on your own. You've got the answers down below. How'd you do on 3? Did you get the answers of x is 4 rad 3 and y is 8 rad 3? Mm-hmm. Okay, good. Go on to 4. Wasn't 4 easier? Actually, 4 is a whole lot easier if you take the 2/14 and reduce it to 1/7. Don't you have a lot less work? It is to your benefit to reduce that ratio if you can before you use it. All right, so your homework tonight is page 409, 4 through 27 of your textbook. Make sure you come in with questions. Make sure you grade your answers tonight. It's imperative.